Alrighty, in this video we are going to be looking at area under the curve. So for number 1 through 6, what we're going to do is sketch the curve that I give you with its interval. And then we are going to find the exact area by using formulas from geometry class. So looking at number 1, where I have f of x is equal to x, I know that's just going to be a straight line. And then if I have from 0 to 3, I know that this is 0, 0. And I know that this is 3, 0, 3, 3. So if I want to look at the area bounded by the curve of the x-axis between the given values, this is going to be my region right here that I'm trying to find. Well, lucky for us, this is just a triangle. It's a right triangle. So I'm going to have 1/2 base times height, or 1/2 3 times 3, or 9/2 units square. I'm going to do the same thing for number 2, where I'm going from 0 to 2. So I know that at 0, I'm going to have a y-intercept of 1. And then if I were to plug in 2 here, I'm going to have an x-intercept. So I have 2, 0, and I have 0, 1. And I want the area bounded by my x-axis and my line. It's another triangle. So I'm going to have 1/2 base times height, 1/2, 2 times 1. My area is just 1 unit square. All right, so looking at number 3 now, let's say that I have the same thing as number 1, except I have 2 to 7. So let's say that I have 2, 2 right here, and I have 7, 7 right here. Well, I'm only going from 2, 2 and 7, 7. And if you look at this, notice how it's a trapezoid. So I'm going to have my area being my 1/2 height, and then my 2 bases. Looking at my 2 bases, it's just going to be 2 and 7. So that's going to be my vertical distance right here. And then my height is going to be my horizontal distance from 2 and 7. So that's going to be 5. So 5, 2 plus 7, 1/2, 5, 9. So this is going to tell me that my area is 45/2 units square. All right, same thing with number 4 here. Instead of a minus, we have a plus this time. So I have 1, and then we have 1/2 x. So we're going to pretend that this is the 1/2 x. Now, if I were to plug in 4 here, let's say this is 4, then I'm going to have 1/2 times 4 is 2, 2 plus 1 is 3. If I were to plug in 8, 1/2 times 8 is 4, 4 plus 1 is 5. It's going to be another trapezoid here. So here I have 1/2 height, base 1 plus base 2. Your bases are going to be the vertical distance. So in this case, it's going to be 3 and 5. And then your height is going to be the horizontal distance from 4 and 8, which is just going to be 4. Simplify this a little bit, and that's going to give me 3216 units square. All right, so now looking at number 5 here, I have the square root of 1 minus x squared from -1 to 1. Well, if I were to think about what this looks like, it's going to look like a semicircle from -1 to 1. and I have a radius of 1. So thinking about my semicircle, we have area being 1/2 pi r square, area being 1/2 pi 1 square. So area is just going to be pi over 2 units. Number 6 is very similar, except instead of a square root of 1 minus x squared, I have a square root of 4 minus x squared, meaning that I'm going to have a semicircle from -2 to 2. However, notice how my restricted region is from 0 to 2. So instead of a semicircle, I actually have a quarter circle. So I have 1/4 pi r squared, 1/4 pi 2 squared. Simplify that down, I'm going to get an area of pi units. All right, so notice how for 1, 2, 3, 4, 5, and 6, we were able to find the area pretty easily because we used, let's say, geometry. In the next video, we're going to look how to estimate curves that aren't really pretty and we can't really use geometry. So something like 1/4 x squared from 0 to 6. So that's going to be our goal for the next video. How do we approximate that and find the area under the curve between 0 and 6 using 4 methods?